All right. So we're going to talk about two situations. Let's say two and a half situations. One is like the same one twice. First, we're going to have the same numbers. So it's the same AX and AX, and it's the same value B and B. The only difference is that the middle is adding and the middle is subtraction. So it's the same numbers, but the middles of the both of them are different. So this is a difference, okay? So what will that occur? First, I would like you to fill out the general formula. What will occur is you get AX times AX. That's A squared, X squared. AX times negative B, negative ABX. B times positive AX, so positive ABX. And B minus times negative B, so negative B squared. Now, like I talked about, the first term and the last term usually is its own independent. But here we have similar terms, negative ABX and positive ABX. This is a negative 1 ABX. This is a negative positive ABX. These cancel out. So your final result. What's up?
How'd you get ABX?
AX times B. So AX times B, you just put all the variables next to each other.
Wait, how'd you do the solution then? Like, what you have to do?
I'll show you with an actual example right here. But this is the generic solution to that generic version. When I say generic, that just means everything's variables, no real numbers. But it is true for all real numbers. Any number you plug in here, when they're the same, and this is the same, and the signs are different, this will occur. So I'll do two examples to say illustrate. So first one, we have 3x plus 2 and 3x minus 2. I'm going to do arrows just because it's a little bit faster. So what occurs here is 3x times 3x, which is 9x squared. 3x times negative 2. 3 times 2 is 6, so it's negative 6x. 2 times 3 plus 6x. 2 times negative 2, negative 4. So this is with actual numbers. Now notice in the middle, we have a negative 6x and a positive 6x. Negative 6x and positive 6x cancel out. So what you're left with is 9x squared minus 4. You're left with A, in this case, A is 3, so 3 squared, which is 9, x squared minus B squared. B was 2, so minus 4. So it's AX squared minus 4. Okay. I'm going to do another example, this time without any number in A, just like a normal number. So x squared plus 5, x squared minus 5. Now, x squared plus 5, x squared minus 5. Oh, not squared, my fault. Just x. My fault now. X plus 5, x minus 5. If I know this pattern, if I know this rule, I can automatically do the answer because they're the same numbers, just one's positive, one's negative. Here I have AX plus B, here I have AX minus B. So what I'm going to do is A squared, X squared. The number in front is 1. 1 squared is just 1, so I don't really need to write that. X squared minus b squared, so 5 and negative 5, which is 25. So if you notice this pattern, you can skip right to the final answer. All right. If you notice this pattern, you can skip to the final answer. All right. That is our first, we could say shortcut or special case. Does anyone have any questions? I'll leave this part up here. Okay. All right. So we have ax plus b, ax plus b. Ax plus b and ax plus b. What that leaves me with seems to be ax plus b, ax plus b. These are exactly the same. All right. Since they're exactly the same, we're going to have a different result. So what would occur is ax times ax, so a squared x squared. Ax times b, which is plus abx, abx. This one, b times ax, which is going to be the same thing, abx. Remember, on these typical situations, you try to keep it alphabetized. And then b times b is plus b squared. Well, this first term is itself, a squared x squared. The last term is by it's the same, plus b squared. In the middle, they're the same term. It's one abx and one abx. So if I do 1 plus 1, what I get is 2abx. Okay. So I'm going to do one long, and then I'll use one using the shortcut. What you get in the middle is going to be double the product.
How did you get 2?
This is 1 abx. This is 1 abx. So 1 plus 1 is 2.
Okay.
So 1 is 2. So let's do an example. 3x plus 2. 3x plus 2. All right, I'm going to do this the long way where I show every step in between. So 3x times 3x, that's 9x squared. 3x times 2 is plus 6x. 2 plus 3x is plus 6x. And 2 times 2 is plus 4. Combine like terms. 9x squared plus 12, 6 plus 6 is 12, x plus 4. So if my a is 3 and my b is 2, what I did here is just do 2 times 3 times my b, which is 2. 2 times 3 times 2 times 3 times 2 equals 12. Now, why is it 12? 6 plus 6 equals 12. That's why.
Why is it not squared?
When you add like terms, you do not change the variables. They only change if you multiply like terms, like 3x and 3x becomes 9x squared. I guess I'll put this on this side. This is technically relevant to here. Okay. So that's an example with a it done out. And then I'm going to show you how to do it as a shortcut or as a rule. Now, very important. Let's say you're in a situation, I don't need a line. In a situation where you like don't remember the special rule, you can always just do it the long way to be safe. Okay, but you do need to recognize these special rules because the next section after this section, or like a 2 sections later, called factoring, you gotta need these special rules, but I'll bring it back up when we get there. All right, we'll do the same thing. Let's do 4x plus 5. 4x plus 5. Here, I'm going to use the shortcut on purpose. So sometimes it helps just to identify my A is 4 and my B is 5. So 4 times 4, A squared. So 4 squared, or 4 squared is 16. X squared plus 2 times A times B. So 2 times A, which is 4, times B, which is, I roll a capital B, times B, which is 5, times X. 2 times 4 times 5, 20, 40. So 40x plus B squared, B times B, 5 times 5, 25. So you could use the shortcut to do it. If you want to do the long way every time, there's nothing wrong with that. That's totally fine. Okay. Now I said there's like 2.5 rules. So let's talk about this last, I guess I would argue half a rule. Maybe it's like 1.5 rules. I don't know how to describe it. So let's talk about this last rule. And I'm going to purposely, let's see if I can condense this. Group smaller. It's pretty good. So the first one we had where we had a plus and a minus. This one, we have a plus and a plus. Does anyone want to guess what we're about to have? First one's plus minus, this one's plus plus. The last combination we can do is what? Is anyone paying attention? Because I could just shut off the stream and whatever. All right, the last one is going to be ax minus b, ax minus b. Now, why I say it's a half a rule, because it's very similar to the rule above. The only difference, it's a squared, x squared, minus 2ab x plus b squared. That's the only difference. So if I had x minus 3, x minus 3, first one would be x squared. Second one would be minus 2 times a times b times x. A is 1 in this case, so 2 times 3 is 6, plus 3 squared, which is 9. All right. Seems like everyone's super engaged, so I don't know how it's going in the classroom. This is just a factor. I'm happy. This is a factor of practice. So what I'm going to do is let you guys go, type here for your attendance. If you're sharing computers, say their name in your here statement and have a wonderful day. I'll post the homework right away. So then you can practice right.
Thank you.
Thank you.
No problem. No problem.
Thank you.
No problem.
Here,
Probably,
Type it out.
Mr. Tobel.
I gotta Jeff, put you down.
Not the first time to call Rabbi. What's up?
Yeah, but it didn't apply to you, did it?
Mr. Tobel.
What up?
Yeah, y'all was here. That's what everyone calls me.
Because we
No,
don't have
type
school
it.
tomorrow, can we not home?
No,
Since
we
we
always
don't have
say that.
school,
You're a real one.
no, we,
You
we
know.
don't have school. They
Hi,
cancel
Mr.
school
Tobel.
tomorrow. We have a snow day.
Get over it.
Shalom.
Guys, we have to go on his Zoom, obviously.
Can we not have
Dance.
homework, please?
Homework included. That's what
I need to know if I have to bring home my notebook.
Yes, you're having homework.
What the heck? Why are you moving?
But I always post a picture of the page, so I guess you don't have to move your textbook or anything. Let's see, what's your homework? Oh, shoot. Three to 15. Perfect.